Now next is the method of adjusting the tonicity and pH. In previous lecture we have to study about the method for determination of pH. After that we have to study about the method of adjusting the isotonicity and pH. The method are classified into two types, class 1 method and class 2 method. In class 1 method, the sodium chloride is added to the drug solution to reduce the freezing point of the solution to minus 0.52 degrees Celsius, and it also adjusts the tonicity with the body fluid. Now second is a class 2 method. The water is added to the drug solution in sufficient amount which forms the isotonic solution, and the final volume is adjusted with an isotonic solution or buffer isotonic solution with the body fluid. These are the two methods for adjusting the tonicity. Now the class 1 and class 2 method are further classified into following categories. The class 1 method are categorized into two types, cryoscopic method and sodium equivalent method. In case of class 2 method, it is also divided into two types, White-Vincent method and Sproul method. Now in class 1 method, the substance are added to lower the freezing point of solution to minus 0.52 degree Celsius, that is the depression in freezing point of the blood. The methods, class 1 method are classified further, freezing point depression or cryoscopic method, sodium chloride equivalent method. In class 2 method, there is addition of water to the drug solution to form an isotonic solution. This method are also further classified, White-Vincent method and Sproul method. Now first is a cryoscopic method. In cryoscopic method, the freezing point depression method are used to determine the adjust the tonicity, not determine, adjust the tonicity. By this method, the freezing point of solution is calculated. The freezing point of solution is equal to the freezing point of the solvent minus delta TF. The delta TF equal to LC. L is the constant of solutions and C is the concentration in case of molarity. This method is a colligative properties which depend upon the concentration. If there is a same depression in freezing point, that leads to the same concentration and which indicates the solution is isotonic or same tonicity. For example, 0.9% sodium chloride solution is isotonic. So the depression in freezing point of the 0.9% NaCl is minus 0.52 degree Celsius. Now next is the depression in freezing point or cryoscopic method. The freezing point of the blood or tear that equal to minus 0.52 degree Celsius. If any solution have freezing point minus 0.52 degree Celsius, that is isotonic solution. If the solution have freezing point greater than minus 0.52 degree Celsius, the solution become hypertonic solution, and if the solution have less than 0.52 degrees Celsius, the solution is hypotonic solution. The solute are added in hypotonic solution to make up the freezing point of blood, to make up the freezing point of solution, which is compared with the freezing point of the blood, minus 0.52 degree Celsius. Now, how to calculate the depression in freezing point? By the formula. The formula for calculating the depression in freezing point or the concentration of the salt, W% equal to 0.52 minus A divided by B. The W% is equal to, it is the concentration in gram per 100 ml of the adjusting substance. A is the freezing point depression of 1% of unadjusted substance in term of X percentage strength. B equal to freezing point depression of 1% solution of adjusting substance. Now next is numerical problem related to class 1 method. Example 1. How much NaCl is required to render 100 ml of a 1% solution of apomorphine hydrochloride isotonic? The depression in freezing point of 1% NaCl, that equal to 0.58 degrees Celsius, and the depression in freezing point of 1% drug is 0.08 degree Celsius. So the depression freezing point of NaCl is given here, and 1% solution of drug solution are given here. So these value put into the formula. W percentage equal to 0.52 degree Celsius minus A upon B. Now the equation is become W percentage equal to 0.52 degree Celsius minus the depression in freezing point of the unadjusted substance, that is 1% drug solution, 0.08 degrees Celsius, and divided by the depression in freezing point of the 1% NaCl solution. So W percentage is calculated as 0.76%. This is the another example. You have to solve by this formula. W percent equal to 0.52 minus A upon B, similar as first example first. The second method is a sodium chloride equivalent method. This method is based on the factor known as a sodium chloride equivalent factor. Sodium chloride equivalent factor. The sodium chloride equivalent factor of a drug is defined as the quantity of sodium chloride which is equivalent with the 1 gram of the drug, is known as a sodium chloride equivalent factor. Now firstly we have to calculate the equivalent of sodium chloride, and after that we have to calculate the amount of sodium chloride to maintain the isotonicity up to 0.9%. Now next is the how to calculate the equivalent sodium chloride. So that is calculated by this formula. Delta TF equal to LC, delta TF of drug, that equal to L isotonicity into X, weight of the drug divided by the molecular weight of the drug, X into V, volume of the drug solutions. Finally we have to calculate the equation, that is equivalent of sodium chloride that equal to 17 L iso of the drug divided by the molecular weight of the drug. So this is the final equation to calculate the sodium chloride equivalent factor. After that, second step is how to calculate the amount of the sodium chloride. The formula are used for the calculation of sodium chloride, that is in term of weight. W percent is equal to 0.9 minus drug percent multiplied by equivalent of sodium chloride. W is the weight of the sodium chloride in gram per 100 ml, which make up the solution in isotonic. Second is the drug percentage, that is a weight of drug in gram per 100 ml. And third one is equivalent of sodium chloride, that is calculated from previous step, sodium chloride equivalent weight to 1 gram of the drug, that is a factor, equivalent factor, and this 0.9, that is a isotonic solution of the sodium chloride. Now next is the example related to the sodium chloride equivalent method. You have to solve the all these examples, example 1, example 2, you have to calculate one by one. Now class 2 method. In class 2 method, first method is White-Vincent method. In this method, the water is initially added to the drug solution to make it isotonic, and the final volume is then adjusted by using isotonic buffer dilute solution. This method is based on two steps. First, addition of water to the drug to make it isotonic, and secondly, addition of isotonic vehicle to bring the solution to final volume. And next is the numerical related to the White-Vincent method. The formula which is used to calculate the isotonicity or adjust the isotonicity is, that is V equal to W into sodium equivalent multiplied by 111.1. Here V is the volume of the water and W is the weight of the drug, and 111.1, that equal to 100 divided by 0.9 of the, that is the isotonic solutions. Now we have to calculate the numerical based on this method. Example 2, you have to calculate example 1, we have to showing in previous slides. Now here is the example second, add volume of water and then complete with isotonic solution. Phenacan hydrochloride, that is 0.06 gram, and boric acid 0.3 gram. Now put the equivalent factor of these two drugs are given here. Now put this equivalent factor into the formula and calculate the volume of the water to isotonic. Now next method is a Sproul method. This is the simple form of the White-Vincent method, and the equation used to calculate the volume is the V equal to W into E into 111.1. But in this method the W is kept constant, so the equation is right as V equal to